Hey guys. Well, most of us by now in the 3D printing community have seen these spiral designs that have two pieces that can pass through one another. If you've printed them, I'd love to know. And many of us also have wanted to create these ourselves and maybe not. Uh, Conforming to a simple cone shape. There's a few other shapes that I've seen online, including a sphere. But I had the need to model one quite a bit different from just a simple cone shape like this. And so I want to show you guys how to do that. Now, before you watch this video, I do want to tell you that there are other people who have gone through this process of teaching you how to model these yourself. This one here is a great one. This is from my 3D print lab. I watched this video and it was very thorough about conceptually how to make these. Now, one thing that I will say that I think I am going to be able to show a little bit better is some of the nuances that come from making these spiral designs when the rotated shape, when the revolved shape is not as simple as a cone or a sphere. And I'll give you some kind of more in the weeds pro tips, things that might help you along that maybe didn't get covered in some of the existing videos that already exist that teach you how to make these. So let's begin. First off, I want to play this animation that I made of this game piece spiral fidget toy that I made. So I'm not an expert in Fusion's animation workspace, but I was able to fairly quickly uh, move these things around, move and rotate, and change the view to accurately sort of give me a rough exploded view and then show an assembly of the pieces, including the spiral down, which is what I really wanted to highlight. That's this area here where I'm showing those two pieces and how they um, fit together and go together. And then I just do a basic sort of view around it. This isn't the what I'm highlighting in this video, but I did want to show that. Let's get to modeling. I've got this file and the colors are different. Hopefully these are a little bit easier to see, the green and red. And they're also Christmas themed. I'm making this game piece for my dad for Christmas. Um, we have a game that uses a lot of these pieces, and it's my goal to make unique pieces for him every year. So let me show you how I did this, and I'll sort of give some tips along the way, things that I ran into that I didn't anticipate. So I started off by taking a picture of the game piece itself, one of the ones that already existed. This was wood. And a pro tip on if you're taking a picture to use as a canvas to trace, I would recommend take the picture from as far away from the object as you can. That improves the parallax issue. If the lens is really close to the object, the flat surfaces, in this case the top and bottom, will have a perspective on them, and it'll be harder to trace. A little bit hard to describe, but I recommend taking the picture from far away and then zoom in to trace it. It'll give you better, more accurate results. So I took a picture, I inserted a canvas on, in this case, the front plane, and then I made a sketch. And the sketch is simply tracing one half. In this case, I used a control point spline. If I edit this sketch, I can go into that. That is spline, control point spline. If you haven't tried this type of spline, I highly recommend it. It gives you so much more fine control over a fit point spline. I use control point splines probably about 90% of the time, whenever I can. And so in this case, you can see I've got a sketch defining it. I've got some unique geometries here, like this spline is actually going above where I want the top of the game piece to be, and this black line and this black line are actually where I want the top and bottom to be. And I found that that gave me a better transition from a smooth spline shape to the perfectly flat bottom that I was looking for. I'll finish that sketch, and then I took that shape and I revolved it. I'm going to hide my canvas now. So I revolved that shape basically in the spline profile, but I did not include this top and bottom surface, and that's how I achieved a flat bottom, sort of a sharper transition on those tops and bottoms. So I did a revolve of that profile. That gives me this. Easy peasy. This is the base shape that I want to turn into a spiral. And one thing I'll point out now is contrasted to many of the existing shapes that that you'll see online. If you'll notice, these shapes will often have a large side and a small side. And that is advantageous because if you haven't figured it out yet, the way these shapes work is practically the same way that a nut and bolt work. There is an inner piece and there is an outer piece, and the geometry sort of tricks your eye, but that's really what's going on. There is a inner shaft, in this case this pink small area that increases in size, and there is an outer ring part, and that is this gold colored piece. So normally you'll see kind of the aspect ratio of these parts being one part is much bigger and one part starts much smaller. So a cone is a great shape for this. Well, my game piece, frankly, does not have that sort of an aspect ratio. The bottom here is just a little bit bigger than this top diameter here. So that's one issue that I kind of ran into, and I'll show you some considerations. I'm going to skip those. I made some planes. I didn't end up using them. So what was very important was this sketch down here on the bottom. I'll show that, and it's a little messy. I'll hide the body. But what I've got going on is an outer diameter. I also have some sketch geometry defining 1/4 of the desired twisted shape. So how can I show that? What that looked like right here was I sweep cut this shape here. A little bit hard to see, but what you're going for here is you're pre-deciding how many fins, if you will, do I want. In this case, this design looks like it has maybe 6 or 8 cuts. In my case, I want 4 cuts. So you can see on my sketch, I've got this cut, and then I have a duplicate that is rotated 90 degrees, this construction line. So you can kind of see I'll be making somewhat of a plus sign shape. So I defined that shape, and one thing is critical. They'll point out this fact in other videos that you'll watch. Make sure that this bottom portion here that meets in the middle, make sure that this angle is, in my case, because I'm doing 4, I need this angle to be 1/4 of the 360 degrees. If this angle is less than 90 degrees, in my case, your geometry is going to come out funny. So make sure that this takes up, in my case, 1/4, because I'm doing 4 revolutions, 4 fins. This needs to be 90 degrees. If you're doing 6 fins, this is going to need to be 60 degrees. So keep that in mind. So defined a sketch down here, and then I did a sweep. And you can see here what I actually selected of that sketch. A path that I needed to follow, I actually did a sketch through the center, and why that needs to be a sketch rather than just selecting maybe an origin line for this path. Path needs physical geometry. It would not let me select just like the z-axis on my origin to use as my path. So I actually had to make a sketch that had this vertical line through the part. I had this sketch line in my original side view sketch. It's what I revolved my initial profile around. So the profile of the sweep is what you define down here in your sketch, and you can play around with all sorts of shapes and designs down here. Get creative with it. In my case, I did 90 degrees, I did an arc, and then a taper down to this radius. Now, you're seeing some offset lines here, and I'll get to that in a moment. Select your profile, select your path, which is the center line, and you're going to want to set your distance to 1 and 1. No taper angle. That would make a tapered thread, if you will, and you will not be able to get these parts through one another. And the twist angle, you can set that at 360 degrees. In my case, I actually set it equal to a parameter that I set up called sweep ang, and that was because I found that I needed to adjust that angle to make it easier to 3D print. And so I'll get to that in a moment. Make sure your orientation is perpendicular and your operation is cut, and you're cutting through that initial solid that you made. Next. Oh, and that's what that looks like. So in the bottom, it is it's not cutting all the way through the edge, but as it sweeps upwards, it breaks through, and then at the top, it is fully breaking through the edge. I then did a circular pattern of the sweep feature, and I did that a full distribution, quantity 4. Again, I pre-decided that I wanted 4 fins. And I would play around with this compute type. Optimized seems to work the most often, but you will run into cases where if you try this and it is on identical, it will not work. So optimized might work, adjust might also work. Just play around with it. So now I have this outer shape, and that looks really good. When I first did this, I noticed that this cross-sectional area, let me adjust that. Not that one. gets, okay, so this cross-sectional area here on these fins gets rather small, and that's just due to the geometry of this game piece. It inherently gets small here, and there wasn't much getting around that. I played around with the initial sketch shape um, down here more and less, and that left more or less material here, and I got it to where I'm happy with it. But you might need to play around with that. Be aware that depending on your shape, you might have some really thin areas. After that circular pattern, I did a sweep pattern as a new body from that initial sketch, and I want to show this. This is why I had those offset lines in my sketch. If you watch this video or some of the other ones on YouTube, they suggest only having one profile down here on your initial sketch, and they'll have you um, they'll have you make a positive and negative shape. In the end, you will then use the offset face tool on your inside piece. This in this case, the blue piece, and you're supposed to offset the faces to create the clearance between the two pieces. So there's some slop. You will need slop. You'll need clearance between these two pieces. I found that using the offset face method only works occasionally. In my case, my geometry is more complicated than a simple cone, and the offset face method for gaining clearance did not work at all. So that is why in my initial sketch I have an outer shape and I have an inner shape. This is my built-in clearance, and so I would change the amount of gap between my outside piece and my inside piece by changing the offset distance in this sketch. Right now, my distance between the two pieces per side is 12 thousandths of an inch. That's about 4 sheets of paper, or very roughly a quarter of a millimeter. So when I did this sweep here, it's a little bit hard to tell, but okay. I am then selecting the inside profile from that same initial sketch, and I am selecting the same center path and all the same values. This is important. You want all the same sweep values as your first one that did the cut. If they're any different, you will run into issues. So again, my twist angle is equal to this parameter that I set up, my sweep ang parameter, also perpendicular. All that is the same. Next, I did a circular pattern of that. And that's funny, my colors came in funny here, but that's okay. You can see here what I mean by this inner angle in that initial sketch. If it was any less, these four would not meet, and you would have some interesting either gaps or extra geometry that you would have to deal with. So they need to meet nicely in the middle like this. Next, I did a combine operation, and it's going to think about it for a moment, and that combined all four of those fins on the inside into one piece. Now if we look at the side, this kind of makes sense. We just took a straight up sweep. It was twisted, but it was straight, and so now our shape on the inside, it kind of looks like an end mill or a drill bit. It's twisting, but it doesn't match the outer profile of the game piece like I want. So the next significant thing that I did is I did a revolve cut, or intersect, excuse me. So I took my initial profile sketch, that is this one, and I used it again, in this case, to cut the outside of my inner fins that I just created. So I selected the profile, the axis to revolve around. The angle is 360. That could also be full. I don't know why it isn't. And then the operation, I did intersect. So everywhere that the profile, this thing here, and the inner fins, everywhere that they both both occupied, keep that and cut away everything else. I hope that makes sense. Um, so that gave me uh, the inner piece also having the same profile as the outside. All those steps were necessary because I can't do this complicated shape the same way as I could do a simple shape. The simple way is you start with two of these solid bodies, you make a copy, and then you do your sweep cuts in one of them, and then you do a combined cut of both of those bodies, and that inherently gives you sort of the outer and inner shape, and then you do an offset face on the inner to give you your clearance. But that doesn't work with complex shapes, unfortunately. Fusion runs into a lot of errors, so that's why I had to do basically all these steps twice. I made the outside, and then with a separate geometry in the sketch that has the offset built in, that clearance built in, I then swept up the solid inside, made those copies, combined them, and then I had to cut away the excess in order to give this green body the same outside profile as the red outer piece. Okay. Next, I did some, let's see, that's an offset. Oh, that does not count. Okay. I made a another piece that was like a longer inner piece. I was going to use that as a tool, but that does not apply here. So let me move on to the next thing that does. In the case of these game pieces, I don't have one on my desk, but they actually receive a magnet in the top and a piece of steel in the bottom, and that allows them to be magnetic to one another. They can stick to one another, and that's just one of the elements of the game that we're using this in. So I got to make a magnet here and a steel piece here. And then I did combine cuts in the green piece to make those holes. That's one way of doing it. I could have just extrude cut those circles and then done an extrude to make the solid bodies for the magnet and the steel, but just different ways of doing things. I find that the combined cut is kind of a nice way of doing things. It's fairly parametric. Then I just did some cleaning up with some fillets. In this case, this fillet was on these outer edges. Now this is something that I ran into some issue with. If I went much bigger than, in this case, 15 thousandths of an inch, this geometry down here had an issue. So you kind of got to play around with your fillet sizes and see what will work and what won't. If you want larger fillets, sometimes you can play around with um, designing those in your initial sketch down here. But keep in mind that sometimes that geometry might be getting cut away or might not be in the final product. So you work with the parameters that you can. In my case, I also cut I think that's an octagon, and I'll show that in a moment. Okay, so I had to define a custom plane that was 2 degrees off of the ZY plane, and that was because when I split this body right down the ZY plane, it didn't align with my part, and that's just due to the twist angle in the sweep operation. Um, Hard to describe. So I did a split body with that plane that I created. That plane, by the way, was an angle or a plane at angle. And then I selected the z-axis and then gave it an angle of 2 degrees. Then I split this inner body with that plane. Now, I should explain why I'm splitting this body in the first place. You might ask, why wouldn't you just print this piece standing up like this? And the answer is it failed every time. It's deceptive even if your twist is at what you would think is like leaving a 45-degree overhang, so it should print right. It didn't, and actually when I sort of probed in Bamboo Lab for what it thought some of these overhang angles were, they were showing up as greater than 60 degrees. So in order to combat that, I was not able to print this piece upright because I didn't want the slight scarring that support material sometimes creates. I want this to be visually nice. So I ended up having success by splitting this piece down the middle, and then I printed it in 2 halves on the print bed. This is the inside. Um, this is the flat face. Now in here, this is the hole that receives the steel piece that mine is receiving. And you'll see this octagon that I cut in here. That was to clear out some material for some glue. This was just an easy printable way of doing this. By no means is this the only way to achieve what I was going for, but I wanted some extra area in here for glue. Next, because I'm splitting the 2 pieces and printing them with this inside face on the print bed, I decided it was best to make some holes on the inside for locating the 2 halves together. And let's see here. Then I extruded some pins. I gave them some chamfers. I played around with offsetting these features for tolerances. I was finding that when I tried printing an 1/8" pin and an 1/8" hole, it did not physically work. They were too tight. The tendency, just so you know, is for, at least on my printer, I have a Bamboo PS1 or P1S. P1S. The tendency is for holes to be created smaller because extra material tends to sort of push in, and so it makes holes small. So I offset these holes accordingly, and I know that you can go into the slicer settings and have hole allowances, but I prefer to just do physical real-world tests and then adjust the model as needed. So I offset some faces in order to make those tolerances work with my little pins here. And then when I tried printing this, I was surprised by this, but it's basically two of these pieces, these two halves. When I tried printing these, I did this with a 0.12 millimeter layer height, so fairly fine. Bamboo slicer goes down to 0.08 millimeter slices, so it's the second finest resolution, and I was very happy with the aesthetics of that layer height, 0.12 millimeters. But one thing that occurred is as they were printing like this, where this didn't happen in my prior tests that had thicker layer lines, when I had the thinner layer lines, this bottom face started to warp, and so it became curved. The top and bottom ends started peeling off of the bed, so this face was no longer planar, and that caused issues. So what I found really helped was to create some extra geometry to basically make a brim in these areas on the ends, but leaving the edges alone. And the reason I wanted to leave the edges alone was because I really did not want to have to manually clean up a brim off of the entire edge. I thought that that would really highlight the two halves, and I want this to be seamless as possible. So I drew these little manual pads on the ends, and I extruded them 0.2 millimeters tall. So only one or two slices, the first two slices on this print, would make this basically, how do I say it? A brim only on the ends. So that tends to hold the ends down when they didn't have that much material before. You can see here this face has a very thin section here. When I sliced this ended up being barely um, two line widths. I'm just using a standard 0.4 millimeter nozzle. And so this did not want to stick down, and this area here and here is also very small. It's not a lot of surface area to stick down and stay down on the bed. So adding this extra material to your first layer or two as a very controllable brim, you control where it is a great way of holding your part down, and it worked flawlessly. The the parts that were curved were rather dramatic. It was quite a significant curve, and with these added brims on the ends, there was no noticeable curve to the part or warping at all. So that is a nice way to do that. And I added those on both halves. So it looks like this. I exported those. I also printed these two little pins, and my goodness, these are small. Overall, these parts are only 2 inches, or just shy of 2 inches long or tall, which is so much smaller in real life than I thought they were going to be, which made these little pins absolutely tiny, but they worked. They worked great to locate the two halves and get them to line up nicely. So altogether, what everything looks like at that point is this. Now, of course, once you've printed the inner green pieces, I just tore off these tabs and it worked great. I used some flush trim cutters to clean it up. Used a flame to clean up that edge and kind of hide the fact that the plastic had been stressed there a little bit. And it looks as if these tabs had never been there at all. And that fine layer height really made the aesthetics of this inner green piece look very, very good. It's hard to tell that it is 3D printed um, for the sake of those fine layer lines. Normally, that isn't the orientation that you would want to print geometry like this, that's round on the top. But in this case, because this piece did not want to print as one piece standing up, this was a sacrifice that I had to make, and it ended up working great. You might not need to do that, but I wanted to share how my project went. And this is what needed to happen in order to do this. So to summarize, these inner pieces have a hole up top for a 6x3 mm magnet. Down here they have a hole for a 1/4 inch steel rod. That's just something that I had, scrap steel rod in the shop, and I cut the rod to length to be flush, and that worked great. And I did print these tiny little locating pins. And if you're doing something like this, I would highly suggest doing this as a very simple way to give you some locational, I guess, to have some registration geometry between the two halves. What I found was these pins alone did not necessarily line up the two halves perfectly, but it was so close, and there was just a little bit of play. What these really helped with was getting it really close so that I could get some glue in between these two halves and then put a clamp on the piece, and these two pins kept the two halves from sliding around and becoming misaligned. So that was really helpful. I had tried this before without these locating pins, and the two halves wanted to slide all over the place, and it was really hard to put a clamp on here. So put it all together. I've got the two inner halves. I've got the magnet, the piece of steel. I printed it with these tabs. I've got this outer piece. And then what I did, if you're not familiar with the animation workspace within Fusion 360, that is, instead of design, you come down here to animation. And in my opinion, it's rather hard to use, the animation area, but you play around with your timeline and you can move around and you can select different components and move them, transform them, move and rotate around and it'll keep track of those movements. And so in my case, I just kept on playing with it until I got something that I was happy with, where it shows those pieces being assembled, and then especially the two pieces coming together. Now, the nice thing about these spiral fidget designs is the two pieces can pass through one another completely, and you can take one piece and you can turn it around end over end, and it'll still pass through, it'll still spiral through, and it gives you a really neat effect. You can see that um, in oh, I did not take a picture of it, but imagine if you took this pink cone and you turned it over, you can pass the two halves through one another, and it gives a really neat effect. So I hope that was helpful. I know it was long-winded, but this is sort of the what I learned works for doing this effect with more complicated geometry. If you have any questions, please let me know in the comments. I'd be happy to answer them and respond. Thank you.